Alright class, today we are going to be doing something different with our video. We're going to be discussing a new topic that's regarding 3D solids, and I'm going to actually have to take it off the computer and into the real world. So here we have these three-dimensional shapes, and you may recognize them from your experiences in middle school and elementary school, but these are called 3D solids, and we're going to group them into two types of groups. One groups are called polyhedra, which is plural for more than one shape. That's a polyhedron. And the other group is called the non-polyhedra. Now, how do we know the difference between polyhedra and non-polyhedron? Okay, polyhedra, which is plural for a polyhedron. A polyhedron is a shape that is made up of only polygons. It's a shape that's made up of only polygons. So the polyhedra are, let's see, this is a polyhedra because it's only made up of polygons. That sphere that just fell on the floor is not a polyhedron. Here we have another polyhedron. This is not a polyhedron, so I'm going to remove it. This is a polyhedron. This is a polyhedron. Is this a polyhedron? Nope, that's not. Move that off. Is this a polyhedron? Nope. What about this? Yes. This one, yes. This one, yes. This one, yes. What about this one? Nope. Basically, anything that's rolling off the table is not a polyhedron. And this, yes. So these are the polyhedron. These are not the polyhedron. And as you can see, the difference is that all of these have what we call faces or sides that are all polygons. Every single face or side is a polygon. Over here, some of the faces or sides may be polygons, but some are not. So as you can see here, we have some circular faces. So that means it's not a polyhedron. Polyhedron, not a polyhedron. Polyhedra, non-polyhedron. Okay? And within the polyhedron, we're going to separate them into two groups. One are called prisms and one are called pyramids. And what you remember from middle school is it's a prism if it has two bases that are parallel and congruent. So this is a prism. This is a prism. This is a prism. This is a prism. Two bases that are congruent and parallel. But over here, not a prism. Now here, this is a prism. Two bases that are congruent. Here's a prism. Not a prism. Here's a prism. So we still have these two sets of polyhedra, but one are prisms and one are called pyramids. Prisms, pyramids. Okay? And as we say, pyramids and prisms, they each have one base, but a prism has two bases that's parallel and congruent. Okay? Now, how do we name these shapes? We name these shapes based off their base shape, and then whether or not it's a prism or a pyramid. So in this case, I've made it easy for you. The bases are colored in green, the base shapes. So in this case, we have here a prism, but the base shape has how many sides? 6 sides. 1, 2, 3, 4, 5, 6. So we call this a hexagonal prism because the base is a hexagon. As we can see, two bases. This is, we know this as a cube, but another word for it is a square prism because the base is a square, or we call this a rectangular prism, but to be more accurate, since squares are rectangles, this is a square prism or a cube. And here we have a smaller square prism with a smaller base. And here we have, in this case, the base, and we know it's a base because it has exactly two of these shapes. The base is a triangle, so we call this a triangular prism. This is a square, another square prism, but in this case, all the faces are not congruent. So we call these square prisms over here cubes, or but this one is not a square prism. It's not a rectangular prism. It's not a regular prism. It's just a square prism because the base is still a square. And we have here some more triangular prisms. Here we have a rectangular prism. The base is a rectangle. And these are tricky because you have three sets of shapes that are parallel and congruent. So any of these faces can be bases. But we just picked, in this case, this shape. So the rectangular prism is tricky. And over here, since we no longer have prisms, but we still, non-polyhedra out the way, we call this, since the base is a triangle, all of them are triangles, we call this a triangular pyramid. And in this case, since the base is a square, we call it a square pyramid. Okay? So, two important things that you're to note about this is that they have their own set of properties. But if we were to add up the faces and add up the edges, which are this line segments connecting the faces, and we were to add, those would be equal to the number of, and the vertices, there's a relationship that holds between the two. And that relationship is in your notes. So let's take a look at your notes. And that's going to be the video for today. Thanks.